अच्छा, लास्ट टाइम हम यहाँ तक पहुंच गए थे विच इज के वो करना था कि डेल्टा जी पे पहुंच गए थे। यू ऑलमोस्ट डन विद दिस, ठीक है। तो डेल्टा जी ये था कि इट वाज द टोटल एनर्जी दैट्स अवेलेबल टू अ सिस्टम, ठीक है, विच इज के यू have energy or heat that is being produced due to enthalpy change, and then there was work that was being produced due to change in disorder. Disorder जब भी बढ़ता है तो हमने वो पढ़ा था कि क्या होता है, work gets produced. If things become more disordered, the piston will start moving upwards. जितना ज़्यादा disorder होगा उतना ज़्यादा useful work will get produced. So disorder was measured that it was the work that is going to be produced at a particular temperature, ठीक है, by the system. तो उसको रीअरेंज करके वी फाउंड आउट के वर्क इज एक्चुअली इक्वल टू माइनस टेम्परेचर टाइम्स डेल्टा एस। ये क्लियर है?
Yes, sir.
और तो हमने लास्ट टाइम ना यहीं पे रोका था कि so Gibbs free energy was the total energy that is available to a system, और it was enthalpy change plus the work that is produced due to a change in disorder. Delta G अगर less than zero negative, that means exothermic, that means the reaction is spontaneous, that means कि वो खुद ही होगा, उस आपको कुछ करने की जरूरत नहीं है. But if delta G is greater than zero, ठीक है, so if delta G was greater than zero, so that meant कि भी वो जो reaction है that is endothermic and overall it's endothermic. It's not spontaneous and it needs energy, ठीक है? So without energy, it's not going to happen. So we did case one, which was कि we have a reaction जिसके अंदर you've got enthalpy change which is negative, exothermic, and you've got an entropy change that is positive, where disorder is increasing. So if you have a reaction which is similar to this, any reaction, so what happens in this reaction is that your Gibbs free energy would always come out to be negative because your enthalpy is producing energy, and delta is positive means that disorder increases. That means that it is also producing work. So minus T times delta S, which is positive, that will come out, give you a negative value. That means that will also be exothermic, okay? So this one will always be negative at any temperature. So it means that this reaction is going to be spontaneous for pretty much all conditions. ठीक है, ये clear है? ये हमने last time किया था.
Yes, sir.
ठीक है, now the next thing was that we're going to do another reaction which was, हमने कोई और reaction किया था? नहीं, we just explained this. अच्छा, so we're going to do another reaction and we're going to find out that when is that reaction going to be spontaneous. ठीक है, so for example, I've got a reaction and the reaction is that liquid, and that's, we're boiling that liquid. ठीक है, so I'm going to try and find out that when exactly is this reaction going to be feasible. ठीक है, तो water liquid turning into water gas. Now I already know that this reaction is feasible or spontaneous at higher temperatures, not at lower temperatures. But how do I prove that using Gibbs free energy? So Pele, can somebody tell me what is the delta H for this reaction?
So delta H would be given in the data book, sir?
नहीं, इसका वैसे ही पता होना चाहिए. I'm not asking for the exact value. I'm just asking whether it's endothermic or
Negative.
exothermic. नहीं, boil करो ना. Liquid turning into gas, right?
It should be endo, right?
हाँ,
Because bonds are breaking.
endothermic, change of state, it's liquid turning into gas. Endothermic, ये clear है सारों को? It's endothermic, right? कि water को boil करना है तो it requires energy, right? अच्छा, entropy change बताओ, delta S. What is that? It's disorder increasing or decreasing?
Positive.
Increasing.
Disorder is increasing.
ठीक है, तो वो भी that's also going to be, I said that's also going to be positive. So disorder is increasing. So in this particular reaction, both are positive. अच्छा, now I already know that this reaction is feasible or spontaneous at higher temperatures. ठीक है. अच्छा, it is spontaneous at higher temperatures. But how to prove that it's spontaneous at higher temperatures? So I'm going to use delta G equals delta H minus T delta S. And I'm going to try and find out कि भाई delta G जो है ना, when is that going to come out to be negative? So if I plug in the values, so delta H has a positive value and delta S also has a positive value, which means that this side, D delta S, actually has a negative value, right? Clear? So one term is,
Yes, sir.
one term is positive and the other term is negative, right? So my goal is to make it feasible. My aim is that delta G comes out to be less than 0. It comes out to be negative. So that means that will only happen kab hoga when the negative part is larger. Okay, exothermic work producing, that's more feasible. So this is larger. So this can only be larger if T is large. Temperature ज़्यादा करोगे ना, so what will happen if you have got a greater temperature, your negative term will be larger, and that will make delta G equal to be less than 0. ये समझ आइए बात?
Yes, sir. I have a question. So it should be like lower than zero, like negative values.
हाँ,
So at zero,
we want the total energy to be negative. That means exothermic. We want it to be producing work or producing energy rather than needing energy. ठीक है? क्योंकि
okay.
if it needs energy, तो उसका मतलब the reaction is not going to happen.
So at what about 0 degree? Like if the value of delta G is zero, so if the
नहीं, उसमें
reaction
तो
is feasible or not?
नहीं, less than 0 पे it's feasible. More greater than 0 पे it's not feasible. ठीक है? और
What
equal to
about precisely zero? Yeah.
वो equilibrium पे होता है.
Okay, sir.
ठीक है? It will be going both forward and backward. अच्छा, so this means that it is going to be spontaneous at higher temperatures. ठीक है? So I've kind of proved that it's spontaneous at higher temperatures. तो ये clear है सारों को? Is this clear?
Yes, sir.
Yes, sir.
अच्छा, और इसी तरह कि we can have freezing कर लेते हैं. ठीक है? So when is freezing feasible? So water liquid है and I'm freezing it. I'm turning it into ice. ठीक है? तो इसके end पे I'm going to make a table. So I know this reaction is spontaneous at lower temperatures. So I'm going to use Gibbs free energy to justify this. अच्छा, इसका enthalpy change जो है ना, that's I think this is exothermic. ठीक है? That's negative. और disorder क्या है इसका? Decreasing है ना? So that is also negative, right? So both terms come out to be negative. Is that clear?
Yes, sir.
तो अगर मैं इसको delta G की value निकालूं ना, I try to plug these values in the expression. So that means कि delta H is negative और वो delta S is also negative. Minus T times. तो ये वाली जो term है, this is actually positive, right? Now, the only way delta G is going to have a negative value is if this is large, the negative term is large, and the positive term is small. और positive term small किस तरह हो सकती है? If T is low, temperature is low. So if temperature is low, so negative term would be large, and that would make delta G less than 0. And that would indicate that the reaction is spontaneous. Is this clear?
Yes.
Yes, sir.
Okay, so it's going to be spontaneous at lower temperatures. So इसको, I'm just going to make a table and इसकी summary लिख लेते हैं. ठीक है, so you've got delta H and you've got delta S और यहाँ पे ना you've got delta G. ठीक है, तो ये वाला scenario क्या था कि if both are negative, scenario number 1, ठीक है, so if both of these are negative, then the reaction delta G will be less than 0 at lower temperatures. अच्छा, उससे पिछला scenario क्या था कि if both of them are positive, so it will be spontaneous at higher temperatures. ठीक है, so delta G will be less than 0 at higher temperatures. अच्छा, third scenario था कि what was the third one? That was the first one that we did. If delta H is negative, जो octane की combustion थी, and delta S is positive, disorder is being created, and the enthalpy is exothermic. ठीक है, तो negative positive, so उस case में negative, it's always negative at any temperature. It's always going to be feasible. तो ये negative हो, ये positive हो, so delta G will be less than 0. It's always going to be spontaneous at any temperature. Reaction जो होगा ना वो खुद ही होगा. ठीक है, और the very last scenario is जो बिल्कुल last वाला है, वो है कि what is missing at the moment? I think this positive, कि delta H is positive and this is actually negative. तो ये वाला जो है ना, this is never feasible. Always greater than 0. So it's never spontaneous. It always requires energy. So ऐसा reaction है ना, it's never going to be spontaneous. It always would be needing either work or heat energy to be applied to it. ठीक है, this reaction will never happen on its own at least. Clear है ये table?
Yes, sir.
ठीक है, बाकी कौन clear है? महर clear है? मिनाहिल?
Yes, sir.
Yes, sir.
अच्छा, so this reaction is तो ये याद रखना है. बाकी इसमें कुछ चाहिए, ठीक है, we'll do past paper questions. मेरा last time किए भी थे थोड़ा सा. अच्छा, पूरे questions करते हैं. So let's start, I guess, with this one. अच्छा, ये calculator पे ना, can somebody just quickly find out कि I told you कि the entropy change of a reaction is what? It's the entropies of the products minus the entropies of the reactants, right? So इसके अंदर the entropy change is already given. Try and find this very quickly, then we can do the next one. ठीक है, 225.7. Or product entropies are SiCl4, that's given as what, 239, minus your reactant entropies, which are silicon is what, 18.7, or plus 2x. Cl का नहीं पता, so Cl2 is unknown, so you have to find what Cl2 is. तो इसका आंसर निकालो, क्या आ रहा है इसका?
So it's minus 223.
माइनस 200
23.
नहीं, माइनस में नहीं हो सकती.
Yeah, I think that's something like
Yeah, the entropy value is never in minus. Entropy change could be minus, but entropy value is always, it's always plus.
plus 223.
So explain why entropy change for reaction one is negative. तो वो इसलिए negative है कि number of gas particles decrease. So less disorder. अच्छा ये हो गया. उसके बाद है next question है इसके, अच्छा ये वाला. Now he says the standard enthalpy change of formation of silicon tetrachloride is minus 640. Reaction one is spontaneous at lower temperatures, but it is not spontaneous at calculated temperature above which reaction one is not spontaneous. As remember, he's asking कि भाई figure out what the temperature is at which the reaction is not spontaneous. Not spontaneous के लिए delta G has to be greater than, it's got to be greater than 0, ठीक है? If it's not spontaneous. Well, endothermic आना चाहिए. Overall, it's going to be endothermic, right? So we're going to solve for this, okay, delta G greater than 0. So what we're going to do is, okay, delta G is what? Delta H minus T delta S. So this thing has to come out to be greater than 0. The enthalpy change, I think, is given. That's kitna hai? That's minus 640 with a given and a minus enthalpy of formation of force in the other. That was minus 640. And the entropy change is also given. That's minus 225.7. So ये जो है, this is minus 640. Temperature is what you're looking for. और delta S जो था ना, वो आपका क्या था, वो ऊपर पीछे given था, that was 225.7. So you have to solve for this. Achha, when you're solving inequalities, so just remember one thing, कि if you multiply an inequality with a minus value, ठीक है, the inequality changes. जिसना 3 or 5 है ना, तो उसमें 5 is the bigger value. But if I multiply both sides by -1, तो अगर मैं -1 से multiply करूंगा ना, तो what will happen is कि इसमें ना -3 is going to be the bigger value. Is this clear?
Yes, sir, but I have a question. आपने 225.7 है, right? तो वो
हाँ
negative
उसको,
नहीं था? So where's the
वो
negative
नेगेटिव
sign?
थी.
Yeah.
अच्छा हाँ, वो नेगेटिव थी. मैंने वो बस, अच्छा एक तो वो नेगेटिव है. Not only is that negative, but it's going to be divided by 1000 as well, क्योंकि that was in joules. ठीक है, this was in kilojoules, तो वो unit same रखना है. अच्छा, anyways, इस value को take it to the other side, so it's going to become minus 225.7 divided by 1000 times t. अच्छा, when you get rid of the minus sign, तो inequality की direction would change. So it will face the other direction. So you can take the 1000 on this side. तो बताओ temperature क्या आ रहा है? What's the temperature above which it's feasible?
Sir, so the sign, okay, that's equal to equal, like we just go and divide that. 225% divided by 1000, then divide by that value.
ये सॉल्व करें ना.
Oh, okay. That's 2028. What's that? 2835. Let me confirm. Yeah, 2835.
It's confirming यार 2835.
Yes, sir.
ठीक है. 2835 Kelvin सही. अच्छा बस इस चीज का just remember this thing कि inequality ठीक है, if you've got a minus sign तो वो the direction would change, ठीक है, of the inequality. अच्छा ये हमने last time किया था ना ये वाला. Did we do this?
No, sir, I don't think so.
नहीं वैसे हमने क्लास में किया था क्या? I think we did कि वो addition polymerization और condensation polymerization.
फिर एग्जांपल की थी
आपने
उसकी।
आपने इसका
हाँ.
बताया था कि उसमें
हाँ.
क्या होता है कि
हाँ ये बताया था कि वो addition polymerization में ना डेल्टा एस नेगेटिव
वो
होता है.
नेगेटिव
ठीक है वो it is delta S negative क्योंकि a lot of gas molecules are just joining up to form one molecule. ठीक है तो the number of particles decrease. ठीक है. और condensation में the number of particles increase क्योंकि every time when ये जो condensation polymers होते हैं ना, a water molecule gets produced, so the number of particles increase, so the disorder kind of increases. ठीक है. ज्यादा particles हो जाते हैं उसमें. तो ये तो हमने खैर किया था. ये पूरा डिस्कस किया था. इसको स्किप कर लेते हैं. अच्छा यहाँ पे व्हाट ही इज सेइंग इज के नहीं इसके लिए आई वुड हैव टू. अच्छा वो उससे पहले ना डेल्टा एच हैज टू बी कैलकुलेटेड. ठीक है. So we're going to try and use your answer to work out the bonds that are broken, the bonds that are formed during the reaction between. So we're going to do this. So although organic chemistry, amide formation, you O levels में किया था. A2 के अंदर ना you're going to do this again. So amides are formed when what happens? कि you have a carboxylic acid and you've got an amine. And they react. So OH and H, they react and they end up forming an amide. ठीक है. और water molecules form हो जाते हैं. So double bond O goes and joins with the NH. And the H and OH, they end up forming water molecules. अच्छा इसमें मुझे बताओ how many bonds are broken and how many bonds are formed? ये reaction है. कितने bonds टूटे?
Sir, what about the OH bond? That's also broken, right? Or will it become one bond for OH?
देखो हाँ ये टूटा है ये वाला bond. ठीक है.
Yeah.
This bond has been broken and this bond has been broken, right? The bonds that are broken is a CO bond and one other bond, which is an NH bond. ठीक है. These are the bonds that are broken. अच्छा पे फॉर्म कौन से हुए? फॉर्म ये हुए C और N के बीच में बॉन्ड फॉर्म हो गए. सो दैट्स वन. ठीक है. सो बॉन्ड्स दैट आर फॉर्म्ड आर C and N. और वाटर के अंदर वो जो OH and H है ना, सो इट्स एन OH बॉन्ड दैट्स फॉर्म्ड. मतलब वाटर के साथ बना है. वो जो OH था वो जो H था, they ended up joining together. That's how water was formed, right? So that's the bond that is formed. तो ये क्लियर है कि by looking at the diagram, it's the CO and NH bond that are broken. ये डबल चेक भी कर लो. CO bond and NH bond. These are the bonds that are broken. Form कौन से हुए? ये जो C है ना, that ended up joining with the N, which is CN bond. ठीक है. So that formed. और वो जो HOH है ना, वो जाके आपस में bond कर गए. So that is the bond that is formed. ठीक है. ये clear है?
Yes, sir.
बस उसने कहा था इसका delta H निकालो ना, तो you can find the delta H by looking at the data booklet. So if you have a look at the data booklet, तो किधर है bond energies? ये अच्छा CO तो I think 350 है. नहीं 360 है. अच्छा CO is 360. NH is I think 390. डबल चेक कर लेते हैं. NH ये So that is 390. अच्छा फिर CN bond. CN bond, that's 305. और फिर OH bond, वो 460 है. Pretty sure it's 460. किधर गया OH ये 460. अच्छा तो उसकी overall enthalpy change will be broken is endothermic, so that's going to be 360 plus 390. And formed is exothermic, so that's 305 and minus 460. तो क्या आंसर आ रहा है इसका डेल्टा एच क्या आ रहा है?
Plus 905.
कितना आ रहा है?
Plus 905.
9 तो नहीं आना चाहिए.
Let me double check. Oh, sorry, I just edited a subtraction. Okay.
-15 आ रहा है मेरा
15 है? 50?
-15
So minus 15 आ गया, ठीक है. So ठीक है, delta H is coming out to be minus 15, right? So that's minus 15 and so वो इधर आ गया, ठीक है, minus 15. ठीक है, we did this working. I said now he has given us, वो कह रहा है कि calculate the minimum entropy change for the reaction to be spontaneous at 298 kelvins. ठीक है, so you want, so again spontaneous करना, delta G is equal to what? Delta H minus T delta S, right? He wants the reaction to be spontaneous. So that means delta G has to be less than 0. Exothermic, ठीक है? So that means delta H minus T delta S को solve करना है less than 0, right? That should come out to be less than 0. The delta H has already been calculated, kilojoules means that's minus 15. The temperature is already given, you're supposed to find it at 298 kelvins times delta S. This को solve करना, so I'm going to do this, minus 15. Take it to the other side, so it's going to be 298 delta S, right? And divide by 298 both sides, so so delta S has to be greater than minus 15 divided by 298. क्या आ रहा है? Or convert this into joules. So minus 15 was kilojoules because he's looking for the answer in joules. So make this kilo, है ना? So this is going to be 15,000 minus 15,000 joules. Divide.
50.3
Yeah.
कितना? तो ये minus 50.3 joules में minus 50.3, ठीक है? तो ये आ गया. So अगला फिर से use the equation and data given in the table to calculate delta G for reaction at 225. So again delta G calculate करना, that's what? Delta H minus T delta S, ठीक है? So for this, the enthalpy is already given. The temperature is given, but it should be in Kelvin, so that's 298 kelvins. Delta S has to be calculated. वो आप किधर से कर लोगे? Delta S is what? Product minus. So that can be calculated. So क्या होगा? It's going to be 26.9 minus the reactants, which is Mg. So Mg कितना? That's 32.7. And the other reactant is O2. O2 has to be divided by 2. तो क्या आ रहा है? What is delta S?
Minus 108.3.
और remember ये joules में है, ठीक है? Joules per Kelvin per mole. ठीक है, joules per Kelvin per mole. So delta H is what? Minus 602. Temperature is what? 298. And your delta S is what? Minus 108. 0.3 ये उसको डिवाइड बाय 1000 में करना है, ठीक है। तो क्या है, व्हाट इज डेल्टा जी? ये प्लस हो जाएगा, ठीक है।
$569
569 minus 569 में minus 569.7
और ये किलो जूल्स पर मोल, ठीक है।